good afternoon, good morning, good evening from wherever you're tuning in from across the globe. We hope you're all doing very well. It's a pleasure of myself and Paul to introduce to you today the new PAS 880. So over the coming slides, we'd like to just discuss some things, foremostly about the market and the reasoning why Phase One has introduced this system, and then look at a bit more details, the specifications of the system.
Yeah.
So just to start off, I'd just like to introduce myself and Paul. So I'll let Paul start with himself.
Yes, thank you. Welcome. Portfolio manager for the PAS system. I have many years of experience from practical mapping, aerial mapping, in charge of relatively large company inside aerial mapping for many years. So I think I know the full range of that part. Been working with production of aerial cameras for the last years, and now in Phase One. So I'm really looking forward to present what we have decided to do. So James, please continue.
Yeah, so I'm James Wardlow. I'm now with Phase One since 3 years. I'm an area and system sales manager for Europe, Middle East and Africa. I'm located in the UK, and my background is from the aerial survey industry. So 15 years of experience as aerial survey operator and project manager. Pretty decent experience for this application. So just a little bit of a background for Phase One. So Phase One was founded in 1993 in Copenhagen, Denmark. So today, Phase One of the core team is consisting of more than 320 employees spread across 11 countries. And then on top of that, further 50 plus partners spread across the globe, across all 7 continents. We are a leading provider of medium format digital imaging systems and solutions. And this is coming from industrial applications, including our own for geospatial, digitization for cultural heritage, and also for the commercial market for professional photography. And we do this through supplying of breakthrough hardware for medium format and large format digital imagery, and also providing more productive and better software solutions to produce more efficient workflows. So the company is, as mentioned, headquartered in Copenhagen. It's also the main center for research and development. And then on top of that, we've also got further research and development units, both in Israel and also in Japan. We've then got our direct sales and support centers. So for North America, we have our sales and support center located in Denver, Colorado. For the European, Middle East and Africa market, our sales office is based out of Cologne, Germany. And then we have a further sales and support center in Hong Kong. As previously mentioned, we also have 50 plus distribution partners, which offers a global network of sales and support centers, which makes us a fully customer-centric organization offering 24/7 customer support.
So when designing a new system, there's of course a demand, and the basic of a modern large format camera is a number or several mid format cameras, and Phase One specialty is large format camera, and that makes sense for us to continue into the large format business. So the demand we see as several demands. There's a large fleet of maybe 700-800 large format camera around the globe, and a lot of them need renewal. But the question is, can we add anything, or what is the next generation? So we see we could make something that could replace the existing large format camera, but there's also a high demand for next generation oblique systems that really so far have had lack of performance, especially for the demand in the city. So what we could see was that we could combine the demand of large format camera and next generation oblique camera system into one unit. So what was of course important was to make it performance so it makes sense. And one of the most important issues for us was to have a high balance between the resolution in nadir and oblique. And I think really we've been able to do a system so we can make flight planning as easy as possible, more or less believing if you have one resolution nadir, then you have the same, at least in the center, on near to the center in the oblique. There was also some demands, especially for the city flying, that you should be able to fly with any types of aircraft and higher resolution. So I think we were able to put it into one box, one compact box. James will come with more details about that. The third one is a low stone, which is very important. That is trust. Many of you have been working with phase one for years. You know that we can deliver, but it's at least 5 years cooperation when you buy a system like this. You need service, we need to support you, and we are aware of it, and the system is built for that. And the second one is that you can be sure that we will not go out and do content business. We will be there to provide large format cameras for you. So what you can do with this combined sensor is that you can take the normal high resolution nadir images like you can get with the 280, a really high dynamic image where you're using the full power of a CMOS sensor and are getting a marvelous image quality with the image that are ready for any kind of photogrammetric work, whether it's vector mapping, auto photos, producing DSM, DTM by auto correlation. At the same flight, we can go in details. You can get the high resolution. This example is from the full coverage of Denmark. All 45,000 square kilometers is covered with a 10 centimeter resolution, both in nadir and oblique. And we see it in several countries in Europe. It's coming, and we are sure that there will come more of this. So you can call it a kind of add-on for large-scale mapping, but it's not only giving advantages in the resolution, we also believe that it really can bring new dimensions to automatic mapping and feature extraction, because you simply can see all objects from all sides. 3D city models is coming. Smart city is running. Smart city have a high demand for having a kind of model where you can store all your information. They want a CAD, they want a GIS platform, and they have a high need for details. So far, it's been difficult to fly with better resolution than 10 centimeters. It's been possible, but we see that I have a picture here from Tokyo. This is giving quite a good idea about the amount of details in the city. And all this, the idea is in smart city to manage all what's going on in the city, even if it's a lamppost or whatever it is. And for this, we saw it as a demand to be able to fly 5 centimeter GSD. And we also saw a need that it was possible to do it with any normal survey aircraft, not only flying dangerously slow, and also from a fair altitude. So by this, we really think we have made a system flexible for flying and doing this very difficult survey when we are competing with large airports around the city or in the city areas. Okay, so there's also a need for corridor mapping. Corridor mapping is something coming up because you buy photogrammetry, and this type of mapping can match the accuracy you normally have in a construction work. Is typically we can now deliver the accuracy you can get by an RTK GPS. So we can fly 2.5 centimeter pixels, and by this we can support it by this high accurate mapping projects for all kinds of corridors, whether it's supply or whatever it is. And of course, you could do it over cities, but we mainly see the demand here. And there we can deliver this impressive. You'll get some examples at the end of the presentation. So the last one I'll present is the demand for environmental mapping, as we call it. You've already seen that in US, any kind of thunderstorms or whatever will release a flight. But you also see subjects like flooding, forest fires, storms, removing forestry, or even, as you can see on the picture in the center, it can be counting birds around windmill farms, these huge offshore windmill parks you will see. And all this you can do comfortable by this system and be able to deliver data very fast. And James will tell a little bit about the idea in that we can check the quality online when we're flying, because fast delivery is often a key for this type of projects. Okay, so let's go to a presentation of the system, and I just need to click here.
Every day, the world is evolving. As new cities and communities are built, there's a need for advanced planning with accurate geospatial data. To answer this growing demand, Phase 1 introduces PAS 880 oblique and nadir system, the new 280 megapixel large format oblique system for high resolution geospatial missions and 3D models. The solution's flexibility enables dual configuration for collecting 3D oblique and 2D imaging. The PAS 880 is based on the established technology of 150 megapixel and 280 megapixel cameras, which comprises the backside illuminated CMOS sensor for perfect image quality. The lens's integrated RS shutter, with its long-proven reliability and high speed, delivers record-breaking actuation capacity. The unbeatable performance of the capture rate contributes to the highest accuracy and quality for effective 3D modeling projects. Ultra-fast writing capability and large storage capacity is provided by the control unit. Thanks to its sleek design and adjustable plate, the PAS 880 is installed in minutes and fit most aircraft. With the new generation Phase 1 software, flight planning, data collection, and image processing are easy and efficient. Phase 1 designed an open system, allowing freedom to work with any leading post-processing software. The PAS 880 is developed with uncompromised quality and the best ROI for 3D and 2D imaging missions. Book your demo today.
So here we are. James, you should be in control now.
Thank you, Paul. Thank you very much for that oversight or overview into the reasons and the markets that the PAS 880 has been developed for. I'd like to now take over and discuss the technical specifications that we are introducing with the PAS 880 that will help you in coming forward with the markets as Paul presents. So just before I continue, I would like to say that in the GoToWebinar taskbar, we also have a section where you can ask questions. Once the webinar is completed, it will be our pleasure to answer any questions that you might have. So looking at the specifications, we start, of course, with the 280 megapixel nadir image. So this is comprising the very latest backside illuminated CMOS sensor, coming with 3.76 micron pixel pitch. The camera is equipped with the 90mm RS lenses, which is offering exposure speeds of up to 1/2000 of a second. And the sensor is enjoying a very large high dynamic range of up to 83 dB with an ISO range of 50 to 6400. For the planning, practical planning application specification, the across-track resolution of the camera is 20,150 pixels across track with 14,118 pixels along track. For the obliques, the system is equipped with 4x 150 megapixel oblique cameras. These are all installed with landscape orientation, which is giving you a much better efficiency, especially in your planning for the side overlap part of the planning process. Again, the cameras are using the Sony backside illuminated CMOS sensor with the 3.76 micron pixel pitch. They have the 150mm RS lens with supporting exposure speeds of up to 1/2500 of a second. Again, the same high dynamic range, 83 dB, supporting a ISO range of 50 to 6400. And quite importantly, as pointed out earlier by Paul, the nadir to oblique ratio of the PAS 880 is 1 to 1.18. And this is important because the closer that you are to a nadir to oblique ratio of 1 to 1 means that you're more flexible for planning, especially in mountainous or hilly terrain, where the GSDs are quite critical in terms of your planning for the overlaps. And the oblique angle of the system is 45-degree mounting angles for all oblique cameras. The cameras themselves, as mentioned, are mounted in a landscape orientation, so it means that the cross-track resolution is the widest across the field of view. So this again supports your planning for efficiency in terms of your side overlap coverage, meaning that you're more efficient. So the 150 megapixel cameras are enjoying a cross-track resolution of 14,204 pixels. And in the along track direction, the cameras are enjoying 10,652 pixels. So looking at more detailed system specifications. So first off, as Paul mentioned, it's a high performance system, the highest performance in its class. It's supporting 2 frames per second, which is allowing more than 8% forward overlap at high speeds. The camera has more than 12 terabytes of storage, which is offering more than 13,000 images per data storage, which is obviously allowing much higher data collections per flight mission. The system is integrated with the Planix GNSS IMU solutions, can be configured with either the AP+50 or AP+60 GNSS IMUs. The system is lightweight and compact design. There's a little bit more information regarding the weights in a further slide, but the system is only 45 kilograms in weight, which again, as a large format and combined oblique system, is making the PAS 880 the lightest system available in the class. It's having ergonomic handles, which is aiding easy installation of the system into the aircraft. Again, it follows more information in a coming slide, but the main message here is 2 people can install this aircraft in under 1 hour. Coming with the next generation Phase 1 software package, it enables simplified flight planning, operation and processing workflows with more advanced user interfaces and more streamlined workflows. Power consumption is 380 watts on average, with 450 watts measured as peak power consumption. And on board, we also are enjoying real-time image analysis for on-the-fly quality control. So all images coming in can be analyzed in real time by the operator, which means he can make more detailed notes in his flight log, so that by the time the data reaches the processing staff, they're already aware of any artifacts, maybe cloud shadow or anything else significant in the imagery which might require a reflight. So forward motion compensation. So we derived the forward motion compensation by utilizing the benefits of the phase one technology. So utilizing the high dynamic range on the sensor, along with the short durations offered by our RS shutter, allows us to minimize the motion received by the sensor. So with the high dynamic range, it really allows us to increase the usage of the ISO without introducing any extra noise or degradation to the quality of the image, whilst maintaining the actual physical blur received by the sensor. And just a quick look to the coverages offered, as Paul mentioned, by the various GSDs for the different applications. So ranging from 2.5 centimeter GSD offered for the corridor planning, right up to the 15 centimeter, which would be typical for rural large area data collect. So what we can see here is with the PAS 880's specifications, it allows us to collect the highest resolutions from the highest flying altitudes. This is significantly important as more air traffic is becoming prevalent, especially around the large business centers, London, Paris, New York. It's more important to be able to fly higher to collect those resolutions. So with the PAS 880, you can really collect the detail from a higher flying altitude. With regards to the system installation, we can see on the image on the right-hand side that the system is there, it's available, we're flying it right now. It's very flexible in its ability to install into aircraft. So the combined system weight when including a GSM 4000 is 74 kilograms. So as we can see in the image inside the aircraft there, it's in a Cessna 207. So it's flexible with the aircraft type that you can fly this in. As mentioned previously, power requirements 380 watts on average and 450 watts max peak consumption, which is really meaning that you can install this in a wide variety of aircrafts without really worrying about the amount of power that's required to generate this system. Everything is included inside the actual sense head itself, so all that's required is one single power outlet from the aircraft and everything's covered. With regards to the installation time, if the aircraft is ready for the installation, so the base plate is already mounted, the GNSS antenna is already mounted, it can take 2 people less than 1 hour to install this system. So it's very flexible in case you have to quickly remove the system, install it into another aircraft for a maintenance reason on the aircraft. It's straightforward and simplified installation process. Just having a quick look over the software solution. So as the software currently stands, we have the IX Plan, IX Flight and IX Capture. So the IX Plan, it enables the fast import of various file types, so digital terrain models, DTMs from direct download from SRTM, GeoTIFF import, XYZ import, base maps and area of interest, support all common formats, DXF, shape, KML, DWG. It allows you to quickly modify and update project shapes, importation of ground control points for detailed planning. On top of the flight planning, we also have various reporting tools. So we can report on project parameters. We can look at various quality control tools to ensure that the planning is really conducted to the standards required by the client. In the aircraft, we have, first of all, the IX Flight. So the IX Flight software enables the planning and execution of the flight, the positioning, sensor management and triggering. It also is collecting in the background log files, which can be used and enable more detailed processing flight reports, greater mission analysis. And on top of this, the system is delivered already with 2 displays, a 7-inch display, which can be mounted to the yoke of the aircraft for the pilot, and then a 20-inch display for the operator, which is really giving the operator the largest display to really view each image in great detail and make sure that the details collected are to customer specification. Currently, alongside the IX Flight, we also have the IX Capture software. So the IX Capture is the camera control software, which is really where the operator is able to fine-tune the camera settings to ensure optimal image quality. So this is done through histogram feedback, which is received by each individual image, along with the EV exposure balance. So you can really see image by image that the settings applied to the camera are the settings that are required to generate the best image quality possible. On top of this, whenever you do require to change an image exposure setting or aperture value, this is applied immediately. So it's applied to the very next flight frame in the sequence. There is no delay in the update of the settings. It has happened, so you can really respond very quickly to changing conditions and adapt the system accordingly. As well as this software being used for the image capture, it's also used back in the office for the post-processing. So taking that image data along with the calibration information from the calibration report, you can convert the raw file quickly and easily to a distortion-free calibrated TIFF, which is then ready for your follow-on post-processing solution. So a quick look to the future. So in development currently is the iX Suite package, which includes updated iX Plan, updated iX Flight Pro, and also iX Process. So first of all, looking at iX Plan. So it's based on the existing application. It brings forward the addition of oblique specific planning, the ability to input oblique system information, and therefore planning the oblique mission. The long-term plan is to remove the current area limitation and also to change the software in the function that instead of just creating individual flight plans, you're now creating projects. So projects including missions. So really making that project management much more streamlined, much more user-friendly. And that will be done through an advanced user interface. We then have the iX Flight Pro. So the iX Flight Pro is a new product. It combines into one single software solution, the flight management and the camera management into one product. It will be done through an advanced pilot display with addition of symbols and functionality, as well as an advanced operator GUI. It will allow the operator in real time to physically monitor each individual coming in. They can go back, review an image. So it really gives the operator the ability to really do quality control in the flight. So utilizing those periods between flight projects or on the flight back to the base of operations gives the operator already the chance to go back through some of the images, make some notes in his flight log, so that then during the delivery of the data back to the office, that can also be combined with the post-flight reports that can be generated from the software to really give the details back to the post-processing team. Further to this, we will have the iX Process. So this again will be new product. It will be based on the existing iX Capture processing capabilities with addition of server processing and improved processing performance. This will also be coming through an advanced graphic user interface, which really streamlines the whole workflow from planning through to process to really offer the data that's coming from the aircraft to the processing team to give them all of the details required to really deliver the best quality data to your customers. There will be a further announcement made shortly for a webinar specific to the iX Suite, and this will be announced in due course. But there will be more specific information for the iX Suite in a coming webinar. But first, just a quick mention to the licensing concept for the iX Suite. So all products will be license controlled. iX Plan will continue being hardware licensed on a dongle. This gives the flexibility that that dongle can be carried from computer to computer. It can be done with flight planning in the office, or the flight planning can be carried out into the field by the operations team, and the flight planning can be done remotely. The iX Flight Pro will be software licensed, will be pre-installed on the iX controller or on the actual control system itself. And iX Process again will be hardware licensed on a dongle. So again, gives you the flexibility. The processing from the raw file to the TIFF conversion can either be done directly in the office by the processing team, or should the aircraft be away working remotely, the dongle license for the iX Process can be carried by the flight team, and then the data can be converted to the TIFF ready for dispatch back to the office for the future post-processing. All license management can be done by remote access by phase one support personnel. So upgrading of licenses, renewal of licensing, or transfer of licensing from one dongle to another will be able to be done remotely by a phase one technician. So just looking briefly over the workflow. So of course it all begins in the office. Your flight plan will be created in the IX plan. From that, the export will be sent across to the flight team, installed onto the PAS 880, and then the flight execution will be done solely by the IX Flight Pro. This is different from our previous architecture where we had in the flight both the IX Flight and the IX Capture. Everything is now, as previously mentioned, will be contained solely in that IX Flight Pro software, making it much more streamlined, much more easy for the operator in the aircraft, no longer having to switch between software. Everything is contained on the 20-inch display in front of his eyes. Once the flight is complete, it then goes back into the office. We do our image and navigation data post-processing, so the GNSS-IMU data will of course be done in the background. The IX process will take care of the raw conversion to IIQ, raw conversion from IIQ to TIFF, and then that will be then transferred into your photogrammetry workflow. So the output that comes out of the IX process will be an orientated distortion calibrated TIFF. This will allow you to import that data into existing workflows without limitations. So this allows flexibility. It allows the flexibility to adapt existing workflows instead of having to subscribe to a brand new workflow. So what we're trying to say here is it's a fully customizable workflow. We're not trying to limit you in where you can work. We allow our customers to be the experts on exactly what software packages they choose to use. So PAS 880, what is included in the delivery? Well, of course, we have the system pod and control unit, which is coming with the 12 terabytes of storage. Eventually, we'll have the IX Suite software package containing a license for IX Plan, IX Flight, and IX Process. There will also be the 7-inch pilot display and a 20-inch operator display. Depending on the customer requirement in terms of accuracy, we would deliver the system with the integrated Planix AP50 or the AP60, and that will come with either the Type 91 or Type 57 IMU. This will also be delivered with a license of the POSPAC MMS and POSPAC Photo Tools software. The system comes fully calibrated, so calibration is already taken care of by phase one in the lab. We also offer on-site installation and system operator training. So this includes installation of the system into the aircraft, the operation of the system both on the ground and in the aircraft, and full software package training. And the system is also coming with a 1-year complete system warranty, which is including system firmware upgrades and software maintenance. Optional extras include extended warranty packages, extended training packages, and also coming for the future, an optional near-infrared channel. So now just looking quickly at some of the imagery delivered by the PAS 880 during the recent testing. So this was an image flown recently at 5 centimeter GSD. And what we can see here is it's really able to offer you the details that are required for these applications. So what we can see in the zoomed in inset is someone enjoying current corona times, taking the surfboard and making use of his daily exercise. Taking a look now at one of the oblique images. So this is a sample from the forward oblique from the same flight. Also with the oblique and nadir 1 to 1.8 ratio, we can see that this image is slightly better now than 5 centimeter GSD. What we like to see about this image is really the benefits that having the CMOS sensor as opposed to the previous generation of CCD sensors is really that the benefit that comes with having that high dynamic range of the sensor. And what we can see here when we look at closer detail of the image is we can get those details that we require. We can see quite clearly, we can see the transmission lines, but more importantly in the areas of shadow, we can quite clearly see all of the details and the intricacies of what is being looked for. So in the terms of a smart city mapping machine, a 3D city mapping machine, having those ability to have a look at the detail in the tight, narrow alleyways of dense urban environments is critical for providing the data that is required to our customers. Now I'd like to hand back to Paul, who would just say a couple of words on the return on investment.
Yeah, so with what you saw, fantastic image quality, which is of course one of the key elements in a system. The other one is the hard business part. So what we can offer here is a significant better performance. By the flexibility of flying 5 centimeter with any aircraft in a comfortable height, we are more flexible. It is difficult to fly in the cities, and we can exactly do it here with the best flexibility possible, and you can fly it with your existing aircraft. So, and the other thing is, of course, we have a very good swath, so we have to fly less. That's why we turned the right and left camera in a position so we have a high overlap that we can do, because we have the fastest shutter speed, or the 0.5 seconds between the images. So we really can have a good overlap for a safe air triangulation. 5 centimeter is, as we see, the new standard for city models. And also we can see, as we started to see the national coverage or regional large area coverage, you can see oblique as the add-on. And by better products, we also mean that you can see automatic mapping is much more, let's say, performable, and will give better results because you can simply see the details from any side. We also see it gives more business options by combining where you normally will be flying with a nadir. You can now offer new products to your customer, or vice versa, and you can simply offer more for a lower price. And also, I think for your business, you simply can have a combined instrument in your fleet. So it's also ready for the future. We see that this system and the design is something you can use for many years. If going to higher resolution than 5 centimeters, we could turn into the problems with face recognition. So we think 5 centimeters will keep for quite a while, and we can also see that you can map the details you want. And we also see that we believe that 15 centimeter will be, 10 to 15 centimeter will be the new standard for large area mapping. It's not like you need to fly 30 centimeter for large area. We really think that 15 centimeter will be a new possibility, but you can use the system in a pressurized aircraft, and you could even fly 30 centimeter if that was a demand. So important, fair price, good performance, and good service. That is what we're looking forward to offer to you. Yeah. So here you have some gentlemen I hope you will contact. They are ready for any of your questions, and they also will be pleased to talk with you about pricing, more performance, how it fits into your workflow, how it fits into your aircraft and your environment, and also to talk more in details. But we're ready to deliver. That's maybe the most important answer or question for you. So now, Tina, have you got some? We have some minutes for questions.
Yes, thanks, Paul. We already got quite a few questions from the audience. So I'm going to start with the first one. How fast can I collect imagery with this system?
Yep, so with the system, currently it's supporting 2 frames per second. So depending on the altitude of your flight and the desired forward overlap is really deciding on how quick the shutter capture or the shutter rate will be. But as mentioned, we can support up to 2 frames per second, which is a consistent figure. So yeah, 2 frames per second.
The most difficult one, 2.5 centimeter, you can collect with 120 knots. So you're well covered. All the rest you can fly as fast as your aircraft are are able to handle.
How much work is required to move between aircraft?
So yeah, essentially the installation, as mentioned, when the aircraft is ready for the installation, so it means that there's a base plate ready for the mount to be attached to. The GNES antenna is already installed. It can take two people up to 1 hour to move the system. So the mount is fastened to the aircraft via 4 bolts. The system is then attached to the top of the mount. And then it just requires the connection to the GNSS antenna and the connection to the aircraft power supply. So there's no external computing units that need to be installed. So it's everything self-contained inside the sensor head.
Thank you, James. Next question is, what's the minimum diameter for the camera hole?
That's a good question. As from what I can gather, it's requiring a 20-inch diameter hole, so a standard 20-inch hole.
Yeah, it's made for a standard survey aircraft port. So we will fit in any normal aircraft, whether it's from the small technical aircraft, it will be fit perfect for the P68, and it will even be able to be installed in high pressurized aircraft. So it's very flexible in the installation, and it's easy to adjust it in height. You can see by the ring, and there's also a quite smart function of handling vibrations, so that should be no problem.
Okay, thank you, Paul. The next question, what about aero triangulation?
Air triangulation is fitting perfect. The idea is that you're taking a lot of images, and today it's possible to do air triangulation with the software where you also include the oblique images, which is giving a much stronger solution. We have a number of recommendations. You can use info software, which we find to both be fast and giving a really good result. But if you're a bingo user, that's definitely also a possibility. Yeah, and we really think with this solution, we can see that you're getting really good results.
Thanks, Paul. Next question is about lenses. So what are the lens options?
Yeah, so lens options is configured for the nadir view with the 90mm RS lenses, and then the oblique views are configured with 150mm lens, which is giving us that that really quite important nadir to oblique ratio of 1 to 1.8. So yeah, at the moment the system is configured with 90mm in the nadir, 150mm in the oblique.
Okay, then we have a question about data sets. Do you provide sample realistic data sets so that we can verify that the system would work with our existing workflow?
Yes, sure. It's available. Just contact one of these persons, and we'll be helping you with the data set that fits to your demand. Yeah, so we're ready.
What's the difference between the two IMUs, and where would I use one over the other?
Yep. So the difference between the IMUs is purely in the accuracy that they provide. So both are extremely high accuracy IMUs. The AP50 is a class 5 IMU. So it really depends on the level of accuracy that you're looking for. So the higher the accuracy of the IMU, the more beneficial it is coming forward in the post-processing sense, reducing that effort of the aerial triangulation in adjusting the images.
Yeah, depending on the altitude. The higher altitude you're flying, the more higher requirement there are for the IMU. And if you want to deliver, let's say, standalone images with high accuracy, it's recommended to have the highest accuracy. But if you're doing air triangulation, the lower class should be fully sufficient for any project.
thank you. And another question, does the customer need to use a Planix or SOMARK, or can they use their own GNSS or IMU or MIND?
There we need to know what you have. And as soon as we have that, we can go into details with it. There will be some possibilities. The same with the gyro mount. We need exact information about what you have, and then we can go in and see what we can reuse. Yeah, that's the easiest way to do it, because there are many details in these products.
And we got another question. What's the diameter of the objective corners?
Can you remember, James? I think that's fit with what the gyro, the SOMARK mount can take.
Yeah, I would have to take a rain check on that one. So if that question could be forwarded to me directly in my email, I'll follow that one up personally.
Okay. Another question, does the software include stitching of the nadir images?
Yep, so the nadir images are provided as 2 times 150 megapixel image, and that will be handled currently by the IX Capture software, which takes the onboard calibration information from both images and performs the stitching through IX Capture, and then eventually that will be handled by the IX process. So what will eventually be exported, ready for the post-processing photogrammetric workflow, is a single central projection 280 megapixel image. So yes, the software as supplied handles that creation of the single 280 megapixel image.
Okay, thanks. Another question coming up just now. You mentioned that you can also use a pressurized cabin. Does the additional glass plate not give any unsightly reflections during the oblique shots?
Normally not. There can be many types of glass. There can be a need for coating, but normally with the type of lenses the system be using, it should not give problems. But if the aircraft have, let's say, not a stable glass plate, there could be a need for changing the glass plate, but there's no special requirement for as such for the glass plate.
Okay, thank you. And another question, can customers send their one phase 1 camera to be used in the PAS 880?
It would have to be done on a use case basis. We would have to assess what the camera was. The lens is slightly different in the system, but certainly if there are existing phase 1 cameras, we can certainly look at using them as collateral as part of the quotation and the pricing, to look at using them as an exchange value.
And then we have another question just asking, is it possible to fly only nadir images with the system?
Simply, yes.
Okay. Next question, how are the cameras, or are the cameras calibrated?
Yes, they are. Yeah, full calibration is provided for all 5 cameras.
We could maybe tell a little more. Really, phase 1 is working on fantastic calibration facilities for the cameras, and the project-based calibration you can do both with the planning software, but also in the info software. There's really fantastic functions to get the last quarter pixel out of the calibration.
Okay, thank you, Paul. Yeah, if there are any other questions, please feel free to ask now. Alternatively, if you have any other questions later, just reach out to us, because that was the last question at the moment.
So yeah, I'd just like to just to remind that we have the contact details for the individual regions listed below. So if there are any more specific questions, or if you would like to schedule a demo or ask for some demo data, please feel free to contact us as per the contacts below. So again, for Europe, Middle East, Africa, including Australia and New Zealand, it's myself. For Asia and Pacific, it's Scott Liu. And for the Americas, we have our colleague Kevin Graville. Yeah, if there are any more questions coming, Tina.
Just another one in regards to calibration services, but I think we've answered that. So will you offer calibration services for the 880?
Yes.
Yes, yeah.
Yeah. And if you're not in one of these regions, just find the one you think looks best or most pretty, and they will for sure hand it over to ensure that the right person will get in contact with you.
Yeah, that's the questions for now.
Okay, well, just like to thank everyone for joining us and for listening to the presentation from myself and Paul. And yeah, just once more, if you have any further requests, please feel free to contact any one of us. So yeah, once again, thank you very much.
Yeah. Bye-bye.